Here's the solution to question 1 of homework 5. From the first question, we must find the density function of x by two methods. Let's begin the first method. Is the convolution method. Here's the solution. We can know that because x and y are independent, and the density function of 0 equals the convolution of the density function x and density function y. And we can get this integral expression, and we can because the density function x equals to ux minus ux minus 1, and the density function y equals to uy minus 1 minus uy minus 2. So we can get this expression, and we can get the whole expression through the distribution law. And let's begin the first expression. We can know that u alpha means that alpha is larger than or equal to 0, and uz minus alpha minus 1 means that alpha is smaller than or equal to z minus 1. So we can get this, and this requires that the z is larger than or equal to 1. So we must times u z minus 1. In the same way, we can get another three expression through the equation above. So we can get this expression through the integrals, and we can get this one by simplifying the equation above. So we can get the results. This is the final results. And let's begin the geometric methods. We know that the distribution z equals the probability of capital Z is smaller than or equal to 0, and equals to the probability of x plus y smaller than or equal to 0. And we can get this figure by the density function x and density function y. So we can get x is larger than or equal to 0, smaller than or equal to 1, and y is larger than or equal to 1, smaller or equal to 2. So we can get this square. Because z equals x plus y, we know that this is can be expressed as a line in this figure. This one is expressed this equation, and we know that because we must get the probability of this one. It means that we must get the area of the shadow of the shaded area, this one, and over to the whole area. So we can, and we know that z equals to x plus y can be meet the square or away the square. So there are three situations. Let's begin. The first situation is for z is larger than or equal to 1, smaller than or equal to 2. And we can know that the line can be this one. So in the the line is this one. So we can get the the distribution of z equals to the probability of x plus y is smaller than or equal to z. And we can know that this triangle, this area of triangle equals to 1/2 z minus 1 square, and the whole area equals to 1, so the probability is equals to this one. And the density function of z equals to the derivation of the distribution of z. So we can get this one, z minus 1. And for z is larger than 2, smaller than or equal to 3, we can know that the line can goes to this way. So we can get we must get this area of the shadow. So this area of shadow equals to the square minus the triangle. So we can get the square, the area of square equals to 1, and the triangle square equals to 1/2 3 minus z square, and the whole square, the area of whole square equals to 1. So the probability can be expressed by this way. And at the same way, the density function of z equals to 3 minus z. And let's begin the final situation. Is z is smaller than 1 or z is larger than 3. And we can know that the line is away from the square, so they are not meet together, and the probability equals to 0. So the density function of z equals to 0. And finally, we can get the density function of z equals to z minus 1 for z is larger than or equal to 1, smaller than or equal to 2, and 3 minus 2 for z is larger than 2 or smaller than or equal to 3, and 0 other situation. And it is the same results as the first result. So this is my solution. Thank you.